Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, in this video we're going to talk about how we can simplify some trigonometric expressions. So in this video we're going to refer back to the fundamental trigonometric identities that we talked about in a separate video. So I will link that video in the cards right now if you want to go back and look at some of those identities. I will refer to those in this video, so just so you know that's where they're coming from, okay? All right, so number one, we have 1 plus cosine of theta times 1 minus cosine of theta. So what I notice is from Algebra 1, this looks like the sum and difference pattern, right? We have 1 and we have cosine of theta, 1 is plus, 1 is minus. So we can multiply these together, we can FOIL essentially, but it's just gonna FOIL out to a squared minus b squared. So this would be like 1 minus cosine squared theta. Okay, now, if we think back to one of our fundamental identities for these trig functions, we know that we had sine squared theta plus cosine squared theta is equal to 1, which would be one of our Pythagorean identities. So if I take cosine squared theta and subtract it from both sides, then notice what happens. We get sine squared theta is equal to 1 minus cosine squared theta. So here we had 1 minus cosine squared theta. Here we also have 1 minus cosine squared theta. So what is that equal to? Well, it's equal to sine squared theta. So number one would simplify to sine squared theta. All right, number two, we have cotangent of theta plus tangent of theta. Well, cotangent and tangent, they are, we can simplify them to cosine over sine for cotangent, and then sine of theta over cosine of theta for tangent. So if I write cotangent of theta as cosine of theta over sine theta plus sine theta over cosine theta. Now, if I want to add these fractions, we have to have a common denominator. So I notice my common denominator should be sine theta cosine theta. So sine theta cosine theta. So to get that denominator, we need to multiply the first fraction by cosine of theta and the second fraction by sine of theta. So that's going to give me cosine squared theta plus sine squared theta. Well, we just saw on number one that sine squared theta plus cosine squared theta is equal to 1. Well, that would also mean that cosine squared theta plus sine squared theta is also equal to 1. So this is just equal to 1 over sine theta cosine theta. So now if we separate those two fractions, we would have 1 over sine of theta times 1 over cosine of theta. Well, those are reciprocal identities. 1 over sine theta would be cosecant of theta, and 1 over cosine theta would be secant of theta. So this one would simplify to cosecant theta times secant theta. All right. Number three, we have tangent of pi over 2 minus theta, and then times sine of theta. Well, one of our identities tells us that tangent of pi over 2 minus theta is equal to cotangent of theta. So now we could rewrite this as cotangent of theta times sine of theta. And we just saw on number two that cotangent of theta is equal to cosine of theta over sine of theta. So now we could say cosine theta over sine theta times sine theta. Well, our sine thetas will cancel out there. So this one would be equal to just cosine of theta. All right, in our last example, number 4, we have secant theta times tangent squared theta plus secant theta. Well, I noticed the tangent squared theta in there, and we do have an identity that tells us that 1 plus tangent squared theta is equal to secant squared theta. So if I want to solve that for tangent squared theta, I could just subtract 1. So now we get tangent squared theta is equal to secant squared theta minus 1. And I'm going to take secant squared theta minus 1 and plug it in right here for tangent squared of theta. So now we would have secant theta times secant squared theta minus 1 plus secant of theta. Now I'm going to distribute my secant of theta, so like this. So now we would have secant cubed theta minus secant theta plus secant theta. And notice right here, those will cancel out. So number 4 will simplify just to secant cubed theta. Okay, and that is how you can simplify some trigonometric expressions.